My name is Michelle Thompson, and I'm an associate professor in the Department of Earth, Atmospheric, and Planetary Science at Purdue University. It was an incredibly surreal moment when they opened the sample canister. I was sitting in a room in Houston at NASA Johnson Space Center with a couple of members from the team, and we immediately saw that there was fine-grained dust, that there was dark rock fragments that was in the sample return canister, and so we knew that we had successfully returned material from asteroid Bennu. Cheers went up around the room, and it was really an electric feeling. So I was a part of the quick look team, which meant we were allocated sample to do the first 72 hours of analysis. So first we just looked at the material visually to see what the fine-grained material and the rock fragments looked like. Then we performed more detailed analyses to understand what the minerals and the composition of the material was. And all of this was really important to get our first understanding about what the asteroid Bennu is made out of. We are very excited about the early results from the sample. We know that there are hydrated minerals, meaning that minerals incorporate water into their microstructures. Now, this water is representative of what would have been around in the early solar system and could have delivered water to Earth and contributed to our own oceans. We also know that there are organic molecules in the sample, and these molecules could be the building blocks that were delivered to Earth and eventually evolved into life. So we're looking at really exciting results, and this is just a taste of what's to come for the analysis of Bennu samples. I think we were all surprised by just how much material was there. Now remember, this is not the bulk sample that's in the tag SAM. This is all material that has just spilled out. So I like to think of it as a little bit of bonus Bennu. And we were so excited to see how much was there. I was immediately thinking about this could provide me and scientists like me with lifetimes worth of work. So we were excited and surprised. So this is really just the beginning. Sample return missions like OSIRIS-REx create a legacy in the collections that they bring back. And so this science team will be working on these samples for the next couple of years, but they really will represent generations of scientists that will come after us who will have access to these materials. We are just at the tip of the iceberg in trying to understand what the composition of these materials are, what they can tell us about the early solar system, and what types of things might have been delivered to early Earth. We did not work around the clock, but it was close. You could barely tear us away from the lab. We were so excited. We wanted to maximize the time that we had available and do the best job that we could for the team and for releasing results to the public. We spent a great amount of time working on the sample, and we kept looking around at each other saying, is this really happening? We were so excited after years of preparation that we were finally performing these analyses. So the science team on OSIRIS-REx will be allocated 25% of the material that we brought back. Canada and Japan are partners on the mission, so they will receive a portion of the material, but 70% is going to be archived and available for scientists around the world and for future generations that will come after us. So there will be opportunities for anyone who wants to study Bennu material to do that. The curation team at NASA is doing an incredible job at keeping the sample pristine, and it will be available in the coming years for analysis around the world. I will continue working with the sample. Once we have access to the bulk sample, which is still inside the tag SAM, we're going to continue with the detailed level of analyses that we've been planning for the last few years.